So we just place the VMs, it's not over, right? The business has to run. So you'll have to balance your load. So when your applications are running, you'll have to do some load balancing in between. So how do we do the load balancing part? So in storage, we understand that latency plays a very important role. So there would be some applications which have to run on a very low level, very low latency data store. So here we have the data stores which are listed at the bottom. There is a virtual machine which is running on a data store which is like 40 millisecond latency. It's high actually. So this virtual machine, when it is running on this, cannot survive. The application on it cannot survive with this particular latency. So it has to get migrated to the one which is the right candidate. So the right candidate here is the second data store which we have. So the virtual machine gets migrated onto the candidate which it sees based on the policy. It has decided, the policy says that this virtual machine has to run on a data store which is like, which has the minimum latency which is offered. And the advantage of this one is in case you want to take out any data store for maintenance, say you have data store like you have NAS, you have fiber channel, you have iSCSI, all these things coming up together, and you will have to perform some maintenance activity on your FC array or something, you are going to bring it down. So the advantage of this, when there is any maintenance which is planned or you're putting some data store into the migration, into the maintenance mode, all the virtual machines which are running on top of the data store will automatically start getting migrated into the other data stores. So at this, because of this, at the time of maintenance and then plugging in back the array into the data center, right? The administrator doesn't have to worry about how the applications are going to run. The applications will still run independently and they would not even know that this change had happened. And this is about the storage and the compute part, what we have spoken about. Now let's talk a little more about the policy management, why policies are so important. So you have got data centers, say Singapore, Bangalore, and Delhi. And then on top of these data centers, you have a cloud infrastructure. You have the entire layer of cloud infrastructure, which is running on top of these 3 data centers. You have these SLAs. Actually, that's bronze. It's looking like gold. It's gold, silver, and bronze. The 3 kind of SLAs what we have. And these are the SLAs. So the SLA says the availability for a gold customer has to be 99.99%, and for DR, RTO, it has to be one hour, and okay, the backup has to be daily. The backup policy has to be a daily backup. Storage capacity has to be 10 terabyte, performance has to be high, and security has to be like pretty high. So this is what the gold says. I'm not reading about the silver and bronze. You can make it out. So here, when we have a VM, a virtual machine which is running an application, an Exchange server, it is coming into your data center with an SLA. So what does actually the administrator has to do? He has to look at the SLA and then see in the existing bucketing model which we have for gold, silver, and bronze where the virtual machine has to fit in. So for that, we need some decision making to take place. And this decision making is not possible if there is a human intervention required each time, because there can be thousands of virtual machines coming in every time into your data center. So you need a placement engine. Sorry. So you need a cross data center and cross cloud placement engine. So what the placement engine does, it makes the decision for you. It's going to read the SLA with which the virtual machine is coming into the data center and sees in which bucket it is going to best fit. So this is a decision maker. What it's going to do is, it's going to check what SLA suits this application. So the ones which are turned red, I hope you can make out. Here. Black is the only thing which is satisfied, and red is the one which is not satisfied. Okay, so if you see, the silver and bronze have not satisfied the SLA for this. So this virtual machine has to get into the gold SLA. So that completes the story about like computing and little bit of automation part. And now in a data center, we have several applications running. We have networks going, we have storage, we have the servers, it's a lot of IT team. So you have data, logs, events, alerts coming in from every place. You have the hardware performance, you have the events, security, admin sections, admin actions, metrics, usage data, and availability data. This data comes in from every place. What are we going to do with this data? How are we going to manage this data? Because this data is coming from every place. If it was just a network admin, the network admin would have taken just the network part, and storage admin would have just taken care of the storage. Now that we are breaking the lines actually. So then we need one place wherein we can see all these logs as a centralized location, and then we'll have to manage. It's not just about showing your logs in one single console. How do we leverage this? I mean, why do we need logs? When Ravi also had mentioned in the previous the previous session, he was mentioning about the cloud computing and mobile computing, how they are merging. So this data, right, whatever we want the data to be useful. There can be some data which is not at all useful. And here, the best part when you have one single thing to manage is, like, say for example, a customer calls you up and then says that, hey, maybe like 5, 6 or 7 hours back, there was a crash which happened on one of my hosts. I'm not sure, can you please fix it? It gets so wild on the admin because, you know, you will have to find out, this is at the data center level and cloud level what we are talking about. So you'll have to drill down so much to identify where the fault has happened, and then you'll have to do the corrective thing. So I have put a screenshot of one of our product. It's actually a vCenter Operations Manager. So what it does is it helps you capture all the events which are happening in your data center in one console and help you take the mitigation action as well. And the best thing about these kind of products is that they'll recommend, they will forecast, they will learn from the usage patterns you had been having. It's a learning thing. They learn from it. It's like artificial neural networks. I mean, they learn whatever they had in the previous, and then they form patterns. And then it can forecast, like what is your data center is going to need. You have hit your 80% threshold at your storage. It's going to tell you, hey, you're at 80%. Go do something about it. We need such kind of recommendation because we cannot manage sitting at like one top level, right? All these things managing would get very hectic. So we have spoken about the software data center actually in a whole. So the compute part, the storage, the network and security, automation and management together forming software defined data center. Now I had the title says like virtual data center, right? So I'll just go about it. So virtual data center is something like, it is something for your logical management. It's like in a class, in a 10th class or something, you have like, you make sections, right? Just for the logical grouping, depending upon number of kids or the second language, whatever. So here we have two virtual data centers. You can have any number of virtual data centers. These are just logical containers which will help you match. And these can be associated with an SLA. Here we are showing two groups, okay, two virtual data centers, which is one is like R&D and the other one is finance. Both of the users who come into these groups will have different set of requirements. They will have to have access to different set of applications, which means there is a policy. There is a policy which is coming along with these kind of users. So what we can do here is, based on the policy, now your virtual machines which are coming into the data center, you just associate them with the policy, and based on the policy, they get logically managed by these particular virtual data centers. So now we have the VMs which were like 8 on top, these have grouped themselves into these logical units. Now we are talking about the provisioning. In the past, I mean little past, not very old, so it used to stand up a server in the lab, configure the network. I mean practically we used to do it when we just started our careers. So we used to, you know, pull like a card, we used to take the server, put it in, find the power cable, run it, fiber channel, find a switch, find a free port, run a network cable. It used to take a lot of time. And these physical connections wouldn't take much time, but configuring it, right, you'll have to log into the switch once, you'll have to log into the storage array, see how many LUNs you want to assign. These things will take quite some time. So if you can bring up a VM in just 2 minutes, provisioning a VM just takes 2 minutes, but we used to take almost like 5 days to configure all these things. The storage, the networks, firewall, security, and having high availability on this particular virtual machine. But in future, where we are headed to, the 5 day 2 minutes is from the previous slide, right hand side, and this is where we are headed to, wherein we have all the services available to us in a container. We just need to go and stand in the container. We make relationship with everyone. We make relationship with storage, network, security, high availability, all the policies which you want to get tied up. And you just pay for whatever space you occupy. You don't have to pay for something which is extra. Got it? So here what it happens is you have these particular things already in place. So you're going to a house which is like fully furnished. And then you don't have to buy anything, right? Then you just have to pay the rent. And then this virtual machine coming here just take 3 minutes. Against the 2 minutes, we are just adding one more minute, just one more minute, and then you have everything done. I mean, you're ready to go in 3 minutes. So this is where we are heading to. And coming to the benefits of software-defined data center, it's self-service, it's self-optimistic, and it is self-healing. So when you see that cart, right, supermarket cart, it's like self-service in the sense you want to go buy a database or you want to go buy a web app or something. You don't have to worry about what SLA I'll have to put, what security I need to be worried about, what storage this application has to work. Just go in a supermarket, just buy a DB, you buy one Oracle database, or you buy one a web application, you buy one Apache. And you pay for whatever you are taking in your cart. You are not paying for something extra. And the meters to assign usage, what it says, it's like you're paying for the usage because the infrastructure is all software. It's available to you. You just have to pay for the usage. And the self-optimizing is like it monitors it learns from the usage cycles. Like we had seen the log management tool, right? The vCenter Operations Manager. So what it does, it is learning from its patterns. It's learning from its usage. It knows at what point of time this application needs high I/O. This application is actually less. These many users are logging in this particular time. The usage is more. All this, it's actually learning, and it can accommodate because it is learning. It is giving you recommendations. And then self-healing. Everything is software. So. And I would just go back to the slide which I had mentioned about like storage maintenance, right? You're trying to bring in one of the data store into maintenance. All virtual machines are automatically migrated into the other data stores. So this, in case any disaster happens, I mean say for example, your host is down or your network switch is down, any kind of thing, the data center, because of the policies and the automation around them and the pooling and abstraction from the hardware to the software, it is able to self-manage. It can come over from the disaster and then still have the applications and all moving. Like if you see the security app edge and endpoint, right? So this edge VM is something which we use for cloud. This is the one which saves all the configuration details. So in case everything goes down, you still have your edge VM up. You can retrieve everything back. It's the configuration because the most important part is configuration. If you have a host, you configure everything, all the switches, the storage, everything. You would have remembered the IQN number somewhere, you return, you configured. Next day you come tomorrow, the configurations are lost. Your data is still there, but your metadata which is pointing to the configuration which is saying that, hey, this virtual machine was actually residing on that particular data store and this was the size. If that data is lost, it is very difficult to retrieve back. And then in a nutshell, I'm actually concluding here. So it's all about, it's your infrastructure services, your network, storage, high availability, security, firewall, which is defined by software, managed by software, and delivered as software. So this constitutes a software-defined data center. And it's all about applications, actually. So applications which we want to run them efficiently, quickly, easily in a software-defined world. Thank you. Any? Yeah.
Hi, I actually have two questions, one for Tulika and one for Lakshmi from SDN. So, Tulika, you mentioned about the central WAN, right? So, I just wanted to know how do you guys take care of the usual problems in a centralized system? Because those are like known problems, right? And secondly, this is a WAN, so where exactly it is getting deployed? Is there any example, tangible example who's using this? some organization or maybe
Well,
Google itself is somewhere using it?
Yeah, so actually, as Lakshmi was pointing out about this software-driven data centers, so we are actually using this kind of open flow sort of software model in our data centers at a lot of places. We are experimenting with them a lot, and we're looking at deploying it further. So, and for your first question, I'm not exactly sure what kind of problems you are thinking.
It's like, it's a centralized thing where, so you had routers and the links between the routers got broken. So same thing can happen with your central thing also, with your
with the
central
software.
server also. So
Yeah.
how do you overcome it? How do you make sure that routers are all the time connected to that central server?
Yeah, so there is this one negative point of any kind of centralized system is basically you need to be able to talk to the centralized system. The system has to stay up and you need to be able to do that. So yes, we still have some redundancy. Like it's not that we don't have any redundancy and anything goes down and we just can't function. So we keep some redundancy, but then the redundancy gets reduced because we can maybe live with one router going down. We can live with maybe two routers going down. But the way to overcome this centralized part is basically you keep some redundancy in your system.
Okay.
And as far the software is concerned, yes, software can have bugs. It can have its own problems. So that, as I mentioned, that we do a lot of testing. Like testing is actually huge. Any software, it goes through like days and weeks and months of testing. But what software-driven network does is that it makes testing easy. So we can actually simulate a lot of different types of networks we want. We can simulate new things which are even like not possible in the hardware, and then with testing we try to figure out that we make it a lot more reliable, the software.
What exactly do you mean by 100% virtualization? Because obviously virtualization runs on a hardware platform, right?
Yeah.
So
We are talking about specialized hardware. There's no specialized hardware. See, in the past, right, I'll give an example wherein a software used to come and say that I'm going to get installed only on this kind of a server. Okay. So when you want to buy that software, you have to buy that hardware also, which is an added cost.
Yeah.
So when you're talking about virtualization, it's all about that x86 data center, very standard data center, on top of which we can still run the high-end applications with the lower cost. It's not that we are replacing. I mean, you cannot replace.
Yeah,
Even virtualization also comes with the server, but
Yeah.
you're packing more and more. You're packing more and more workloads, more and more applications in just one.
basically density is what you mean.
Exactly. The higher and that's what when I mentioned about like CPU, the innovation which is happening in CPU and memory, right? The density is more. Everyone wants more with less. In $100, you want like 100 things.
Yeah.
So that is where the 100% virtualization, what it means, it is virtualization which runs on the standardized hardware.
Basically you mean you're using 100% of the hardware. That's what you mean.
100% of the hardware will get utilized because of the workloads what you run. No one wants to, just have these machines and then do not run anything, right? They want to use the best utilization. Your maid is there for 1 hour in your house. You make sure that 60 minutes she's tied up. You don't leave anything, right? So that's how the business runs. I mean, everything has to be 110% of usage, efficiency, optimistic, automated, holistic, and resilient.
All right.
Yeah, we can scale a lot, with virtualization.